Alright, Assalamualaikum warahmatullahi wabarakatuh and good afternoon. How are you? Okay. The schedule is a bit not so good. Friday, also in the afternoon. So, yeah, but it's okay. We try to be focused. Okay, yeah. Okay. So, actually, today I'm just going to go through briefly with the teaching plan. Okay, what we are going to study in dynamics in this semester, and then what is dynamic, what is the difference with static, and how is the marking scheme we're going to see. Okay. Okay. Firstly, I want to introduce myself. My name is Kusendarsya Saptaji. I'm from Indonesia. You can call me Kus. Okay. This is my office. My office in Block D, ground floor. So it's near the stair. Okay. If you want to meet with me, if you want to discuss something, you can come to my office. This is my office number and this is my email. Okay. Okay. So normally I will upload the lecture notes in Kalam. Okay. So you don't need to write down everything. Okay. And I hope that you going to bring the lecture note to the class. Okay. So either you print yourself or you bring in laptop or you want to photocopy from me. Which one you prefer? You bring yourself, okay? So this is some example of the lecture note for next week. So I can print in one page like 4 slides, okay? So you can save some of the paper, or you can print also 2 slides in 1 page. And then during the class, normally I will give example, okay? So in the example, I will give some slide, 1 slide or 2 slide for you to write down the solution. Okay, so you don't need, maybe you don't need to bring book if you already have this slide. Okay, so you can write down directly in the space that I give in the slide. And also we will have, because this is dynamic, a lot of calculation, so we are going to do more exercise. Okay, in the sense that we are going to see some problem and then we solve together. Okay, so in that exercise also I give the same thing, like this the problem, then I give 1 or 2 slide empty for you to write down the answer directly. Okay, and then I also hope that you read the notes first before coming to the class. Okay, so then you have some idea what we are going to study in the class. Agree? Agree. Any question? Okay. Okay. So this is the course overview. You need to pass static. Okay. And then the credit for this subject is 3 credits. We are going to have 14 weeks with 4 hours in 1 week. And then I also teach another section for BFF, okay, on Tuesday and Thursday. So our schedule is Tuesday and Friday. I haven't changed this. I will change. So Friday 3 to 5. Okay. Okay. And then this is the reference books. Mainly the source will be coming from the first book by Bibler. Okay. So you can buy this book or you can borrow from library, and sometimes also you can find free soft copy in the internet. I think there are some, if you search in Google. You also can refer to this book, okay, same dynamic, and also this book. But mainly this is the main source for this subject. And also sometimes the exam question we take from this book. Okay, I think it's better you have this book for this subject. Okay, so before we start, dynamics is basically the advanced more toward the engineering from physics, right? If you can refer. So I would like to give you some intermezzo, okay? So you're not so that stressful. Okay, so let's see this kind of experiment. You know Galileo, right? Do you know Galileo?
Yep.
So Galileo is
Galileo.
sorry. Yeah, Galileo is a famous physics. Okay, so he come up with the argument that basically, I mean, he he did some experiment, which is gravity experiment. So what he did is like he dropped two different material from the same height. Then he wants to know which one is uh, touching the ground faster. Okay. So for example, in this case, we have steel ball and a feather. Okay. So let's say these two material we drop at the same height at the same time on the earth. Which one will drop faster?
The steel ball.
The steel ball. If we drop it on the moon,
Same.
the same. Why?
No gravity.
No gravity and no air resistance. No. Yeah, vacuum is the same, like no air resistance, right? So yeah, basically, then do you know that the astronaut have proof about this? Do you know? No? Maybe let's watch this video.
Well, in my left hand I have a feather. In my right hand a hammer. I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here and hopefully they'll hit the ground at the same time. How about that? Mr. Galileo was correct in his findings.
So Galileo is correct. So it also proved that human already landed in the moon, right? Because some people still argue whether they are really landed on the moon or they just make some movie. Okay. Okay. So basically, this is the basic equation that prove about this kind of Galileo gravity experiment. So this is basically, what is this equation? Newton. No. First, second, third, fourth, second law. Okay. Okay. So before we going to discuss about the dynamic, I would like to see this kind of case. Okay. What is the difference between static and dynamic for this case? Okay. Let's say we have a car, Volkswagen, like this, and then what makes we argue that this car is in the static condition? What? It's not moving, right? Constant velocity, is it static or not? Constant acceleration is it static or dynamic? Dynamic. I'm talking about static first. Okay. So in the static, it means the car is not moving, right? So if the car is not moving, if we relate to the force that we have studied, what is the condition of the force? Equals zero. It means equilibrium, right? So the sigma force is in equilibrium. It means total force in x direction, in y direction, and z direction is zero. Okay. How about in dynamic? What makes we say that this car is in dynamic condition?
Acceleration.
Got acceleration. So it means the car is moving. There is net force. Yeah. So it means the net force is not zero. Okay. So why this car can move? Because it has engine. So the engine, what the engine give to the car? Huh? Force.
Trust.
What force?
Trust.
Huh?
Jawab lah pun.
What force?
Rotational force. What is the name we call rotational force normally? Torque. Yeah. So the engine produce torque. Okay. The engine produce torque in here, and then the car will move. So when the car moves, sometimes it has constant acceleration, right? It will have acceleration. It will have what? Velocity. When the car moves from one point to another point, it will have distance and direction. We can equal in the distance and time, right? Correct. So this is basically we call it the kinematics. Okay. So this that we are going to study part of the dynamic that we are going to study. And beside that, the car can move because of the torque. Torque will produce the moment. Okay. This car also can move if we push, right? Push means we will have some force. Okay. And then there will be some work produced and also energy. Okay. So this is called the kinetic. Okay. This kind of relation we will see later on is about kinetic of the dynamic. Okay. So basically, if we see in mechanic, okay, the definition, okay, mechanic is basically the study on how the bodies react to forces hitting them. Okay, so if we have forces acting on the body, then how this body will react. So that's called the mechanics. So mechanics, it has two different part. One is static. Static is basically the study of body in equilibrium. So you already mentioned sigma f x equal to 0, sigma f y equal to 0, and sigma m equal to 0, something like that. Okay. So this is called we can simplify that. Basically, this is the Newton's third law. Okay. So law number 3 of the Newton is principle of action and reaction. So because there's a action, then there will be a reaction. So then all the forces will be 0. Okay. The second one is that dynamics. Okay. So dynamics we divided into two: is kinematics and kinetics. Okay. So kinematics I just mentioned. Basically, we are going to study about the aspect of motion, how to relate displacement, velocity, acceleration, and time without reference to the cause of the motion. So this is the Newton's first law. Okay. So basically, in kinematic, we are not going to see how big is the force, how big is the energy. We're just going to see the displacement, velocity, acceleration, and time. Okay. And then the second one, we are going to study about kinetics. So then, from here, we are going to see the relation between forces, mass, and the motion of the body, which is considered as Newton law number 2. Okay. And then we also going to expand not only about force, we are going to see about energy, momentum, and etc. Okay, so why you need to study dynamic? Okay, there are a lot of applications. You see, you can apply when you are working maybe in the car industry. It's useful for moving structure and also for fixed structure subject to shock load. Some robotic device also need fundamental of the dynamic, rocket, missile, even spacecraft. Okay, so a lot of things can be useful if you learn about dynamics. Okay, so this is the teaching plan. So what we are going to study for dynamics. Okay, basically there are four topics. Okay, 4 topics. Yeah. So the first topic is kinematic. Okay. So kinematic is basically related to this. We start next week. We are going to study about the planar rigid body motion. There are three rigid body motion: translation, rotation about fixed axis, and then we are going to see about velocity, acceleration, and also instantaneous center of zero velocity. And also the last subtopic of this one is relative motion analysis using rotating axis. Okay, so this is one of the application about this. We are going to see some problem, for example, about gear. Let's say we move gear A, it has certain angular velocity, angular acceleration. Then what is the velocity for gear C and what is the velocity or acceleration for gear D? So how to calculate this kind of problem. Okay. The second one, we are going to study about planar kinetic of rigid body, which is force and acceleration. This is the Newton laws number 2. Okay. We are going first to see about mass moment of inertia. This one you have studied this, right? In static, so we're just going to refresh again. Okay. And then we see 3 equation of motion for translation, rotation about fixed axis, and general plane motion. Okay. And then the third topic is about work and energy. Okay. We are going to see what is the work produced by the force, and then what is the work produced by the couple moment, principle of work and energy, and conservation of energy. Okay. So the last topic will be about impulse and momentum. Okay. So we are going to see what is the linear and angular momentum, principle of impulse and momentum, conservation of momentum, and eccentric effect. Okay. So this is some example of momentum. Okay, so you can recall this. Okay, so we have 5 CO. By the end of this semester or by the end of this course, you are able to fulfill this 5 CO. Okay, so CO1 is related with the chapter 1. CO2 will be almost the same with chapter 1. CO3 is chapter 2, CO4 is chapter 4, and CO5 is chapter 5. this. So CO1, CO3, 4, and 5 will be related with the problem analysis. Okay. CO2 will be related to design and develop solution. And CO2 also for PO9 for communication. Okay. So CO2 basically we are going to fulfill this by doing a project. Okay, so later on we will have a project. Then you need to design something, and then you need to present that design. Okay, that's why PO3 and PO9. Okay, so this is the assessment. Okay, so basically we will have 4 quizzes. Okay, so each quiz is for each chapter. Okay, so quiz 1 for chapter 1. So normally I will do the quiz at the end of the chapter. Okay, so the percentage is like this. So beside the quiz in the class, I will also give you homework. So this homework for you for practice. Normally it will have 2 or 3 problems. Okay, and then we will have tests, 2 tests, test 1 and test 2, 15% and 15%. So test 1 maybe in the week 8. Okay, week 8 because we are going to have break at week 9, right? And then final exam is 40%. So normally like this. And then the project is 15%. So 5% for the design, 5% for the report, and 5% for the presentation. Okay, so you have to have some strategy. Okay, how can you pass this subject? Okay, how many percent you can get from quiz, from test, from project, and from final exam. Okay. Okay, so as you know, also you will fail if you get marked below 39. Okay, then you will pass if you get the above. Okay, you already know this. How about attendance? What do you think attendance? Is it important or not? Important. Maybe. Yeah. So basically, this attendance is not really. There's no mark for attendance, right?
Yeah.
But sometimes lecturer, right? They will see the attendance of the student when this student has the mark in between. Let's say you have 38. Okay, and then this lecturer remember that this student always come to the class and he familiar with the face of the student, and also this student quite active, and sometimes he will check again the mark whether he can upgrade or not. So this attendance is not directly giving you the mark, but it gives some indirectly. Okay, so why also this important? Because for this subject we are going to do more exercise in the class. Unless you are already, you feel that you're confident that you can do all the exercise, all the problem in the book, then you think that you don't need to come to the class. It's okay, but you have to prove that your mark is good. Okay, that's why this is up to you. You are already not in the high school. You don't need to be pushed to coming to the class. So it depends on you. Okay. Okay. Any question before I continue? So far, okay? Or it's too fast or too slow? Okay. Okay. So how are we going to conduct this teaching and learning of dynamic? So this is my method. So I'm going to give you the theory and the concept in the lecture note. You can read through before coming to the class, but then I will explain again in the class, but briefly, the key point only. Okay? And then we will do some example. Okay? We will do some example. Maybe for one subchapter we do one example, or for two subchapter then we do one example. Okay? This example I will show you how to solve it. Okay? You can follow. And then we do also exercise. I will give you exercise. Let's say for one chapter there will be like 6 or 7 exercise. This exercise we do together. You do by your own, and then I will give you some uh, some suggestion. Okay. Okay. So basically, this is how to solve the problem in the dynamic. Okay. So you can read this step again, maybe after a few weeks. Okay. So something funny. Yeah, if you have something to discuss not related with the class, you can go. Then you come back. Okay. So sometimes maybe it will disturb the other. Okay. Okay. So the problem solving, how to solve the problem in dynamic. Okay. So the first thing you have to read carefully the problem. Okay. You have to read carefully. Maybe you need to repeat again, not only one. Maybe you need to read again. So then you understand what is the question, what is the noun, what is the unknown. Okay. After that, draw any necessary diagram. Okay, so diagram is important in this kind of static dynamic. You need to draw to sketch the diagram. Okay. Then after that, establish a coordinate system. Okay, so coordinate system also is important. Coordinate system. What is this coordinate system? X, Y, Z, right? Okay. So then you have to draw what is X direction, in which direction X, in which direction Y. So sometimes different problem, maybe you need to use different coordinate system. For example, if this box is in the flat surface, maybe XY is like this. Okay, but sometimes the problem, maybe this box is in the slanted surface. Then you can use maybe XY is like this. Okay, then you have to refer this when you calculate. For example, sigma fx. Then you have to use this axis for x, this is for y. Okay, and then you need to solve the equation algebraically. It means you need to remember the equation. How to solve this kind of problem using which kind of equation. Okay, and don't forget to have consistent set of units. Okay, when you do the solution, remember the final solution. You need to write down also the unit. If it is force, then you need to write Newton, right? Okay, if velocity, then you need to write maybe meter per second. Okay, so this unit is important. And then you need to check again the solution. Okay, whether it makes sense or not, and you check again the problem. Okay, so this is the step. You can read again this when you do the problem later on. Okay. Okay. So before we go to the dynamic, okay, we do some refreshing with these trigonometric identities, because a lot of mechanism that we are going to solve in the dynamic will involve trigonometry. Okay, so you have to remember again about the sine equation. What is sine? Is between A and C. Cosine is B per C. Okay, tangent is sine per cos, so it will be A per B. sine square theta plus cos square theta equal to 1, and this one also. So this, I hope you still remember, and you need to refresh again your memory. Okay, and then we are going to use mostly vector. In static also use vector. Okay, so what is the difference between vector and scalar? This is the common question. Direction and magnitude. Scalar is only the magnitude. Okay, so in vector normally we will write down three components, right? I, j, and k. So I to represent in x, j, y, k, z. Okay, so this to represent what? Ax, the magnitude, right? So this is magnitude, this is the direction. Okay, so this is the value or the magnitude in I, the magnitude in j, and the magnitude in k. The total magnitude will be square root of this. Okay, so this value is scalar or vector? Scalar, right? Okay. Yeah, this is important. Later on in the some of the system in dynamic, it will have vector. Okay, and then the vector product. If we do cross product between two vector a cross b, this is the scalar result, ab sine theta, but it has also vector product, so the vector will be c. Okay, then how to define the c direction? You know, huh? Right hand rule. Okay, so right hand rule, let's say if we have j cross minus k, what will be the result? J cross minus k. J cross minus k. Minus I. That you already know. No, only some of you thinking about this. You don't know about this? Huh? The cross product? No? Never study cross product vector? Or you forget? Okay, so you just remember this. This is I, J, this is K, right? So I, J is in the plane. K is outside the plane. You draw like this, right?
Yep.
This is I, J, this is K, right? So it means this will be minus J, this will be minus K, this will be minus I, right? So J cross minus K, we have J. So normally I use like this. J cross minus K is going inside. Minus K. Then you will get minus I.
Yes.
Okay, remember again? So like this. Like this. It's like the magnetic flux. Remember magnetic flux? Or you can use like this. Yeah. Like this. J minus K minus I. Right. Same like that. So you have J minus K and I. Minus I, sorry. Okay? Let's try with another question. I cross minus J. Ada? Huh? Negative K. Negative K cross negative I. Hmm? J. Okay. Still confused? Any question? So this is important also. The factor, cross product factor. Okay, we are going to use it quite often in the some of the topic. Okay, so you have to get familiar with this. Okay, so use this. Some of you may be using this kind, right? You know this, like this, right? I'm not familiar with this. I prefer this one. You can sketch this in your answer, just small axis, so then you can imagine what is the solution. Okay. Okay, then we have also dot product. So scalar cross product is vector. The result will be vector. So cross product, the result will be vector again. Okay. So if we cross product the vector, then we will get another vector. If we do dot product, then the result will be scalar. There's no direction. Okay. Okay, so another important thing before we go to the topic of the dynamic is the position factor. Okay, so position factor is basically factor that represent directed line between 2 points. Okay, graphically it is an arrow with head and tail. So position factor showing the value and the direction, okay, between 2 points. Okay, for example, this is position factor RDA. So it means it's basically position factor from A to B. Okay, from A to B. Okay, so we need to write down in the component because this is planar. So there's only 2 components, I and J. Okay, so then we need to write what is the length in I, which is 0.3, and what is the length in J, which is 0.4. Okay, so RBA we write down like this. In the Hibbeler book also they write down like this. So it's basically from A to B. So from A to B, this is the position factor. Okay. If we want to know the opposite, R from B to A. From B to A, so then I will be minus because it goes to the left, minus 3. And then J also will be minus B because it goes down. Right? Then it is minus 4. Okay? So RBA is from A to B, RAB is from B to A. This is how we write down also in the book also it's stated like this. Okay, any question? Yeah, maybe we finish early today. Okay, maybe you do this. Okay, we do some practice. Okay, you need to find the position factor of RAB. It means from B to A. So this is B, this is A. So what is the position factor? RDC from C to D. Okay, and RBC from C to B. Okay? Okay, let's try.